Hello everyone, let's provide a solution given this math problem, which is x plus 3 raised to power 4. This is equal to 81, okay? So from what we have here, we can express this as x plus 3, okay? Raised to power 2, okay? Raised to power 2 again, subtract. Now we take 81 on the left hand side, so this is the same thing as subtract 81. This is equal to 0, all right? Now, as you can see, we can express 81 as 9 raised to power 2, okay? So this means that we have x plus 3 squared raised to power 2, subtract 9 squared, this is equal to 0, all right? Now, from what we have here, you find that this is actually in the form of difference of two squares expression as a squared minus b squared. So x plus 3 squared raised to power 2 minus 9 squared, this is in the difference of two squares. A squared minus b squared, which is actually equal to a plus b, a minus b, okay? Now from what we have here, we're going to express this as x plus 3, okay, squared, okay, plus 9. And then we have x plus 3 squared, subtract 9. This is equal to 0, okay? Now from what we have here, we have two parts, which is x plus 3 squared plus 9. This is equal to 0. This is the first part. And then we have x plus 3 squared, subtract 9. This is equal to 0. Now this is the second part, okay? So the first part, this is x plus 3 squared. This is in the form of a plus b squared. This is actually a squared plus b squared plus 2ab, okay? So actually you have two parts here. The first part is x plus 3 squared plus 9 is equal to 0. And the second part is x plus 3 squared minus 9 is equal to 0, okay? So if you check here, x plus 3 squared, this is actually in the form of a plus b squared, which we can express as a squared plus b squared plus 2ab. Now from what we have, you find that this is the same thing as x squared plus, now here we have 3x times 2, which is 6x, plus 3 squared, which is 9, plus 9, this is equal to 0. Now we will have x squared plus 6x plus 18, this is equal to 0, okay? So this is a quadratic equation in the form of ax squared plus bx plus c. Now our a from the quadratic equation is 1, b is equal to 6, and c is equal to 18, okay? So let's substitute this in the quadratic formula, which is expressed as negative b plus or minus the square root of b squared minus 4ac divided by 2a, okay? Now from what we have here, this is the same thing as negative 6 plus or minus the square root of b squared, which is 6 squared, which is 36, subtract 4 times 1 times c, which is equal to 18, okay? Divide everything by 2. So that you're going to have negative 6 plus or minus the square root of, this is 36, subtract, this is 18 times 4, which is 72, divide by 2, okay? Now from what we have, this is negative 6 plus or minus the square root of, now this is negative 36. If you say that 6 minus 72, this is the same as negative 36 divided by 2. So this is equal to negative 6 plus or minus the square root of, now we can express this as 36 times negative 1 divided by 2, okay? Now from what we have here, this is the same thing as negative 6 divided by 2, which is negative 3 plus or minus the square root of 36, which is 6, and the square root of negative 1, which is I, divided by 2, and this gives us negative 3 plus or minus the square root of, plus or minus, this is 3I. So that means that we have two complex roots here. That is x1 is equal to negative 3. Okay, this is negative 3 plus 3I, and x2 is equal to negative 3 minus 3I. Okay, so these are the first two complex roots. These are the first two complex roots. So let's solve the second case. For case 2, we have x plus 3 squared, subtract 9 is equal to 0. So x plus 3 squared, this is in the form of a plus b squared, which is actually a squared plus 2ab plus b squared. Okay, so let's express in this form. We're going to have x squared plus, this is 3 times x, which is 3x times 2. So we have 6x plus 3 squared, which is 9. Subtract 9, this is equal to 0. Okay, 9 subtract 9, this is 0. So you'll have x squared plus 6x, this is equal to 0. Now from what we have here, this is x squared plus 6x. X is common, so we factor out x, so that we have x plus 6, this is equal to 0. So here we have that x is equal to 0, all x plus 6, this is equal to 0. And this means that this is x3 and x4 is equal to negative 6. You take this plus 6 the other side, so this is negative 6. So from what we have here, we have 4 solutions. We have 4 solutions. Okay, that is, we have the complex root, that is x1, which is negative 3 plus 3i. x2 is equal to negative 3, subtract 3i. x3 is equal to 0, and x4 is equal to negative 6. Okay, the first two, these are two complex roots. Okay, two complex roots, and these are two real roots. Okay, and these are the solutions. So let's verify that the 4 solutions satisfies the equation. Okay, so x1 is equal to that is negative 3 plus 3i. So if you recall, we end at x plus 3 raised to power 4. This is supposed to give us a value of 81. So let's substitute this value of x1. So we'll have negative 3 plus 3i plus 3. This raised to power 4 is supposed to give us a value of 81. Okay, so this is negative 3 plus 3. This simplifies, so you have 3i raised to power 4. This is supposed to give us 81. Okay, so what we have here, this is the same thing as 3 times I times 3 times I times 3 times I, and then times 3 times I. Okay, so this is supposed to give us 81. Okay, so from what we have here, this is 3 times 3, which is 9. 9 times 3, which is 27. 27 times 3, which is 81. Okay, so this is 81 multiplying by, this is I times I, which is I squared, which is negative 1, and then I times I, which is I squared, so it's negative 1 times negative 1, which is 1, which is equal to 81. So it's true that x1 satisfies the equation. Let's check x2. x2 is negative 3, subtract 3i. Okay, now from what we have, we will substitute back to this equation. We're going to have negative 3 minus 3i raised to power 4. This is supposed to give us 81. Sorry, plus 3. So this is negative 3 plus 3. We'll have negative 3i raised to power 4. This is supposed to give us 81. So again, this is negative 3, okay, times I times negative 3 times I times negative 3 times I times negative 3 times I, which is supposed to give us 81. So this is negative 3 times, this is 9. 9 times 9, this is 81. Times, this is I times I squared, which is negative 1, times I squared, which is negative 1. So this times 1, this is equal to 81. So both x1 and x2 satisfies the equation. Let's check x3 and x4. So let's verify x3. So our equation is x plus 3 raised to power 4. This is supposed to give us a value of 81. Okay. Now from what we have, this is like 0 plus 3 raised to power 4. This is supposed to give us 81. Now we have 3 raised to power 4, which is equal to 81. 3 raised to power 4 is the same thing as 3 times 3 times 3 times 3, which is equal to 81. So this is 9 times 9, which is 81. And that affirms that x3 satisfies the equation. So let's check x4. Okay, x4. Now for x4 is equal to negative 6. So let's confirm if negative 6 satisfies the equation. So we have x plus 3 raised to power 4. This is equal to 81. So x is negative 6 plus 3 raised to power 4. This is equal to 81. Now we'll have negative 3 plus 3, which is negative 3 raised to power 4. This should give us a value of 81. Now from what we have here, this is the same thing as negative 3 times negative 3 times negative 3 times negative 3. This is supposed to give us a value of 81. Negative 3 times negative 3, this is 9. This is also 9. So 9 times 9 is 81. So 81 is equal to 81. Okay? And that shows that the 4 solutions satisfies the equation. So thank you for watching. Follow the steps. See you in the next video.